at the reactions with water parts.
We had discussed period 3 and then what we had done was we had discussed ये वाला part के melting points, boiling points, right? We had talked about the electrical conductivity, and we had started talking about the reactions with water. And I told you that this part pretty much is all about just memorizing the reaction, that sodium is a soft metal, reacts with water, produces a very strong alkali, and it's a vigorous reaction. Sodium reacts very vigorously, violently with hydrogen, and hydrogen gas is produced. You see effervescence or bubbles of hydrogen gas. Magnesium reacts with steam, does not react with cold water. It requires a higher temperature. Magnesium is not very reactive. Aluminium is not reactive at all. Aluminium does not have a reaction. Why? Because it's got a layer or coating of Al2, a non-porous, unreactive Al2O3 coating that protects it. Silicon, phosphorus, sulfur, no reactions. Chlorine, on the other hand, has a reaction in which it reacts with water, produces two acids, chloric 1 and hydrochloric acid. Okay, then there's some stuff about oxidation states. You need to know that NaMgAl, that's +1, +2, and +3. Silicon is +4, like in SiO2, SiCl4. Phosphorus has two oxidation states, +3 and +5. The common ones. It can have more oxidation states as well. Sulfur, the common ones are +4 and +6. And for chlorine, it has a lot of oxidation states. It can go up till all the way up till +7 as well. I'll just quickly discuss why period 3 elements have multiple oxidation states. And the answer to that is if you look at chlorine, how many electrons does it need in its outer shell to complete its outer shell? I mean, chlorine is a group 17 element, right? So roughly क्या होगा कि how many electrons does it need?
6.
No, it's a group 17 element. So how many electrons?
1, right?
एक second. मैं तो ऊपर देखा, sorry.
क्या होगा? How many electrons does a group 17 need? It needs 1, right?
Sir, एक और
No, that I just want to correct this. It doesn't actually need 1 electron. Remember a period 3 element has how many shells? It's got the octet rule, that it needs 1, right? So then let me remind you that a period 3 element actually does not need 1 electron. It actually needs it could gain a lot of electrons. So 17 electrons. The electronic configuration is 2 in the first shell, 8 in the second one, and then there's 7 in the last one. ठीक है, तो एक से इसको set कर ले. So 2, 8, and 7. So you got 2 electrons, and you've got 8 electrons, and you've got 7 electrons in its valence shell. I said, now what you've learned is that it needs 1 electron, but it doesn't actually need 1 electron. The third shell, do you know how many electrons can accommodate can occupy the third shell? क्या होता है maximum electrons that can be in the third shell?
18.
ठीक है, in the third shell you can have a maximum of 18 electrons. Is this clear?
Yes, sir.
Yes.
So remember, the octet rule that you know of, that is only limited to period 2 elements, because only the second shell elements, they can have a maximum of 8 electrons. A period 3 element can have a lot more than 8 electrons. It can have a maximum of 18 electrons. So chlorine can bond with different elements. It can try and attract electrons of different elements. Just similar, it can bond with 7 fluorine. It can attract an electron of fluorine. It can attract another electron from another fluorine. It can attract another electron from another fluorine. So that's 3 electrons attracted. So now it has 7 plus 3, that's 10 electrons. It can still have 8 more electrons. It can bond with more fluorines as well. So the idea is that chlorine can have multiple oxidation states. There's no limit to it. It can keep on gaining electrons until its outer shell is complete. But it never actually gets complete. Do you know what's the reason why it cannot actually have a maximum of 18 electrons? क्या reason होगी? Why it cannot have a maximum of 18 electrons?
सर की स्पेस नहीं बचती.
हाँ ठीक है, स्पेस नहीं बचती. ठीक है, you run out of space. क्योंकि you can't have that many fluorine surrounding it. ठीक है, let's say hydrogens are गए, so you can't have so many hydrogens or fluorines or any other atom surrounding it. You can have maximum five fluorines, 6, maximum 7. Even 7 is pretty hard. Like if there is, let me just check if there is ClF7. So there is ClF7. So this is a 3-dimensional. This is an IAF7, by the way, but you can see that it gets completely surrounded by 7 fluorines, and you no longer have any space left for other fluorines. So you can at best gain a maximum of 7 electrons. So the idea is that chlorine can have many oxidation states. It can make 5 bonds, it can make 4 bonds, it can make 3 bonds. So there's no specific limit to it. Okay, so is this clear?
जी sir.
Yes.
And the same goes for sulfur. Sulfur is in group 6. So remember this, that it doesn't need 2 electrons. It's in group 6. The maximum electrons it can have is 18. So sulfur can be bonded to 6 fluorines. Like there's a molecule that's SF6. So जो SF6 का molecule है ना, like if you look at the dotted cross diagram for this, it's forget the I mean this one. Yep, I guess. So you can see that sulfur over here is gaining electrons from 6 fluorines, and but its outer shell will still not be complete. It's still not going to have 18 electrons. So but it has the capacity to even gain more electrons if there are more electrons available. ये बल्कि ज़्यादा सही diagram है. You can see the fluorines bonded to it. But anyways, keep this in mind that a PHC element can have a lot more bonds than it usually. So chlorine can have a lot more bonds than just one. ठीक है? तो ये बात clear है?
जी sir.
Then more memorization. More memorization is that you have to learn about. नया वाला syllabus भी, I'll just open it right next to it so that we don't miss anything in the new syllabus. Just a second. 2022 one. So chemical periodicity. So the reaction, right, equations with oxygen, for the reaction of elements with oxygen, or make the in terms variation of oxidation numbers, in terms of the outer shell, we just talked about that. Right, equations of the oxides with water. So I think we are about to do this part, ये वाला part है, or pH वगैरह, ठीक है? So let's talk about this. So we've got oxides with water. Sodium oxide is a very soluble oxide. It reacts with water, forms sodium hydroxide. That's a pretty strong alkali. It's a very soluble alkali. Magnesium oxide with water is going to form magnesium hydroxide, but it's not very soluble. So what happens is that since it's not very soluble, most of it will just form a crystal at the bottom. Very few OH ions will be produced. So it's not going to be very basic. So the pH would be around 8 to 10. Then you've got aluminium oxide. And aluminium oxide has absolutely no reaction with water. It's completely insoluble. Doesn't do anything. So this one over here is completely insoluble. Then you've got phosphorus oxides. Phosphorus oxides are two types. You've got P4O10, you've got P4S6. one of them has an oxidation state of +5, the other one has an oxidation state of +3. इसमें ये मैं correct कर लूं कि P2O3. अच्छा, the P4O10 is also sometimes referred to as P2O5. ठीक है, so it's also sometimes referred to as P2O5, and P4O6 is sometimes referred to as P2O3. So they react with water. The higher oxidation states ends up forming phosphoric acid. That's phosphoric acid, HCPO4. It has an oxidation state of +5, and it's very acidic. And the other one ends up forming phosphorus acid, and that also is also acidic. So you can say that the pH is let's say the pH is 2. Okay, if you were to make a wild guess, the pH is going to be, let's say, 2. बल्कि check भी कर लेते हैं एक second. As a pH, remember, it depends on concentration, so the pH could vary. You learn about calculating pH in A levels. So अगर 0.1 mole per dm cube phosphoric acid होगा ना, so what is the pH of that? That's probably going to be 1. Let's check कर लेते हैं. K is 10, so that's a correct option. The other B, pH is 2. Okay. Anyways, you have no idea right now how to calculate the pH. Okay, so it is 2. So I guess 2 is fine. pH 2. अच्छा, तो anyways, तो आपने बस एक graph guess करना. It's going to be strongly acidic. Sulfur trioxide and sulfur dioxide, the one of them has +6 oxidation state, the other one is +4. They're going to mix with water. They're very soluble, and they will form sulfuric acid or sulfurous acid, and they'll also be very acidic as well. Okay, is this clear?
जी सर.
तो ये सारी चीजें, you have to remember this, all of it.
Even the pH, sir.
Yep, you need to remember all of that. Okay, so you need to remember. I mean, they'll ask you like magnesium oxide with water. Like, what's the? I mean, they'll ask you for the reaction as well, even the equation as well. So they'll ask you all of what is written over here. Okay. I said then you've got another thing, which is the reaction of chlorides with water. So the syllabus में जो new syllabus है, 1 second, let me open it. It's chlorides with water. I guess it's this one. This is the oxidation state, the reaction. I mean this one. So describe and explain and write equation for the. So we're going to do that later. But describe, explain, and write equations for the chlorides of water with water, including the likely pH of the solutions obtained. So same thing. It's given over here. Now what happens is the very first one, NaCl. That's a white solid. You need to know this the thing as well. कि अगर मैं ना यहाँ पे, if I mean, you should even know what the colors are. Like P4O10, that's a P4O10 जो है ना, phosphorus pentoxide. What's the actual? It's a, can't be the other, it's a, just 1 second, phosphorus pentaoxide. It's a white solid. And what is phosphorus? तो इधर मैं add कर देता हूँ this phosphorus pentaoxide. That's a white solid. ठीक है, ये यहाँ पे लिख लेते हैं. That's because they assume that you've actually seen this stuff in the lab, which you really haven't. Okay. Al2O3 ka SiO2, most of them are actually white solid. These are all white solids, all of them. Okay. SiO2 is sand, it's silica. The silica is, I mean, sand is silica. Okay. Glass is silica. So silica, depending on nature ke andar na how it's present, it's I mean it's basically glass. It's slightly transparent. I mean it's like glass, right? So that is kind of whitish, but not really white. It's transparent. Aluminum oxide, that's also a white solid. Remember, transition metals hote hain na, they're the ones that are actually colored. Aluminum oxide, magnesium oxide is also like I mean they're all like salt, NaCl. Magnesium oxide will also be a white solid. Okay, NaCl, that's also a white solid. So remember the colors as well. Sulfur trioxide and sulfur dioxide, these are gases. These are acidic gases. तो आपका जो SO2 है ना, colorless ही होती है, ठीक है? You don't really have a color, but sulfur dioxide, a toxic gas, I don't think इसका भी color होता है, ठीक है? Trioxide का भी you don't really have a color. तो it's kind of colorless. It doesn't really have any color specifically. But remember, these are acidic gases involved in acid rain as well. So moving on, chlorides with water. So you've got NaCl and you've got NaCl, again, it's a white solid, reacts with water. It doesn't react with water. It actually dissolves in water. Okay, what happens? What is dissolving in water? Like if you have NaCl dissolving in water, it looks like this. It dissociates. Okay, so अगर आपके पास NaCl है and it dissolves, so this is what's happening. Okay, the lattice is dissociating. It's what's a good picture for this? It's एक second. Yeah, let's see. So the ions are kind of getting scattered in water. Okay, that's evil के सही है. ठीक है, so dissociation means that your ions are dissociating. Okay, the ions were all tightly packed, but now what has happened is now what has happened is that you're stirring it vigorously, so the ions, they get completely surrounded by water molecules. Okay, and not only do they get surrounded by water molecules, the water molecules actually get attracted to it, because water is a highly polar molecule. It's the oxygen is very electronegative, so the oxygen has these spare electrons, these lone pairs as well. So the water molecule has a very strong negative charge. So that's called an ion dipole attraction. Okay, I mean this force of attraction. The word that's used for that's an ion. So that's an ion dipole attraction. Ion dipole attraction में क्या होता है कि when the sodium ions dissociate, the water molecules quickly come in and they surround it. So when they dissociate from the crystal over here, they can no longer form the crystal back again because they're completely surrounded by water molecules. Unless you get rid of all these water molecules, जो anions or cations के ऊपर ना the water molecules are sticking to it. Unless you get rid of the water molecules, the ions will no longer be able to stick together and they wouldn't be able to form the crystal back again. Is that clear?
Yes, sir.
Or उस process को ना you call it crystallization. That is that once you try to get rid of the water molecules, the ions will start getting together again and they'll start forming the crystal back again. Achha, but anyways, NaCl, remember, it only dissolves. It doesn't really do anything. Okay? There's no reaction with water. Okay? It's just that the ions, they just get scattered in water. So which is why you have a very neutral solution. It has exactly pH 7. Is that clear?
Yes, sir.
Yes.
अब उसके बाद है you've got MgCl2. MgCl2 with water, that's very slight hydrolysis. When I talk about hydrolysis, that means there's going to be a reaction with water. इसके अंदर भी ये कि it mostly dissolves, most of it. So it mostly dissolves and there is very little hydrolysis. Okay, that's happening. Why is there a hydrolysis? Okay, the answer for that is, and what is hydrolysis? Same thing happens. कि जब आप MgCl2 को ना पानी के अंदर मिक्स करते हैं, MgCl2 magnesium chloride is very soluble. It dissociates into Mg ions and Cl ions. And what you have is this thing. So what you have is that the magnesium ions and the Cl ions are going to get surrounded by water molecules, right? The water molecules are going to come in and they're going to get attracted to it. So if there's a water molecule that's floating around, that water molecule will, it's going to come in, it's going to get attracted to this Mg, which is +2, and it's going to stick to it. But then what happens is, water ka jo H hai na, that has a slight positive charge, and Mg has a very large +2 charge, right? So if it's got a very large +2 charge over here, ये जो Mg आपका है, if it's got a very large +2 charge, तो वो क्या करेगा? It's going to repel the H positive, right? So there are chances that the H will get knocked out, and it is going to be repelled, and the H+1 will dissociate. A few of the H+1 in water molecules, they might get knocked out. ये बात समझ आइए?
जी सर.
Yes.
So when H+1 ions get produced, that is the solution turning acidic. Okay? So what happens is, this is the reaction that is happening. So the reaction is so the reaction is, so the reaction is that the MgCl2, transparent. Anyway, so the reaction is that the MgCl2 will react with water just very slightly, and it will end up forming magnesium hydroxide, like Mg+2 ions and OH ions, right? OH ions are produced. So the Mg will attract the OH ions from water. It's going to repel the H+1, so it's going to form MgOH2, which is a solid. So there's going to be some precipitation that's happening, and the H+1 are going to get knocked out. There was already Cl ions, so some acid is going to be produced. You'll have some hydrochloric acid getting produced. Is this clear?
जी सर.
Yes.
So आपका जो solution है ना, उसके अंदर you just don't have Mg+2 and Cl ions, you also have a bit of acid being produced as well, which is why, and remember, the hydrolysis is not very strong, so which is why the pH is like very slightly acidic. Okay, there's a few of the H+1 ions getting produced, right? So the acid happens to be just very slightly acidic. अब यहाँ पे एक question है कि why did NaCl not hydrolyze? What was the reason for that? मतलब ये बस लिखा हुआ है इसके ऊपर ही. Like Na had a +1 charge, right? So the repulsion factor wasn't really there. Is that clear?
सर तो यानी हाइड्रोजन के दरमियान और सोडियम आयन के दरमियान कम रिपल्जन थी.
हाँ, तो वो तो जिसकी वजह से ना the H+1 did not get knocked out.
Okay, sir.
But the water molecules did not break down. The hydrolysis did not happen. So there was basically no reaction. You just had Na+1 stick, and there was a water molecule sticking to it. That's it. This case, when there was no reaction, there was no bond being broken, right?
जी सर.
So वहां पे there was a stronger repulsion, right? So the H+1 from the water molecules, they got knocked out. But again, it's very slight. It's not that strong. Okay, Amit, clear? Unair, is this clear?
Yes, sir. Yes.
अच्छा, next जो चीज है वो ये कि if I talk about aluminum chloride, now for aluminum chloride, it also dissolves. It's very soluble, but now the hydrolysis is very strong. ठीक है, you've got a very strong hydrolysis. और क्या reason है strong hydrolysis के? Aluminum has got a +3 charge, right? So repulsion का factor क्या है? I mean, when the water molecules get attracted to it, the hydrogen ions, the H positive part of the water, there's going to be strong, there's going to be very strong repulsion. Is that clear?
जी सर.
So how about the layer of oxide around the aluminium cell? Is that gone now?
Yeah, because we don't have aluminum at the moment. It's already aluminum chloride, right?
Okay.
ठीक है, we're talking about aluminum chloride. तो वो पहले से react कर चुका है, ठीक है? So we know there's no aluminum oxide at the moment. अच्छा, so important thing, you've got a strong hydrolysis, and this is what happens. Your reaction is that initially aluminum dissolves, forms Al3 plus aqueous, then that Al3 plus gets surrounded by water molecule. That's called a complex ion. Whenever a metal is actually roaming around in water, there's ion dipole attraction, and the ion gets surrounded by water molecules. That's known as a complex. So the aluminum getting surrounded by 6 water molecules. The water is neutral, the aluminum is +3, so the whole thing has a +3 charge. This entire thing will have a +3 charge, right? And then what happens is that 3 of the positive H ions are going to get repelled. So why not the 4th one? Well, why not 4 H plus ions?
Is it
Sir, the
because it's
force
3 plus,
of
sir?
the reaction with me.
हाँ, क्योंकि अच्छा उसकी रीजन ये है कि you need a positive charge to repel a positive charge, right? So once 3 positive H ions get repelled, what is the charge on the whole thing? It doesn't really have a charge anymore. Okay, you've got 3 OH ions and you've got a +3 charge. So the net charge on the entire thing is now it's neutral, right? The whole
जी sir.
whole complex is now neutral. So neutral thing will not repel a positive H. Is that clear?
जी sir.
वो शुरू में repulsion इसलिए थी because the whole thing had a +3 charge. The aluminum had a +3 charge, right? And the water molecules were neutral. So there was a big +3 charge, and they were all knocking out the positive H ions, right? But once it's neutral, it no longer repels H plus ions. So the other H plus ions, they're not going to get knocked out. Or you किसी भी water molecules में से the H plus one would have gotten knocked out. So is that clear? That usually you end up with AlOH3. You can actually have AlOH4 as well, by the way, but that's kind of not very likely to happen. ठीक है? Is this
Okay sir.
you clear?
जी sir.
Yes.
So the thing is that you have to remember all 3 reactions of chlorides. First one, NaCl just dissolves, no hydrolysis, nothing. Okay, it's a neutral pH. NgCl2, it's got a bit of a positive charge, so very, very slight hydrolysis. Some of the hydrogen ions are going to get knocked out. That will result in the production of HCl or just a few more H plus ions, so it's going to be acidic. And when the case comes for when you talk about aluminum chloride, then there is a very strong repulsion. You've got a very strong hydrolysis, and a lot of the H positive ions are going to get repelled. So you have strong repulsion and there's strong hydrolysis. So remember this, all of this reaction. You got to remember all of this. And this one is a solid. So the solid, the aluminum hydroxide is a solid. So that's your white precipitate getting formed. And another thing that happens is white fumes of HCl gas are formed. It's a vigorous reaction. Like, what did all the H plus 1 do? They ended up reacting with the Cl minus 1 and they ended up forming HCl gas. So, यहाँ पे अगर दिया हुआ है, let's see if we can aluminum chloride with water, ठीक है? तो अच्छा वीडियो के अंदर ही शो कर देता हूँ, बस ऐड ना चले, just a second.
Covalent halides typically
अच्छा ठीक है.
hydrolysis.
अच्छा so
Vigorous and exothermic. The aluminium chloride.
अच्छा so just one second, मैं इसको break करके ना. So this is aluminum chloride is adding a few drops of water to it. Immediately what will happen is you'll start seeing these fumes of HCl gas being produced. the H+ are getting knocked out and they're reacting with the Cl ions and they're forming HCl gas. So you'll see a lot of HCl gas being produced. So that is one way of forming HCl gas. Okay, you'll see a lot of fumes of. ये तो खैर NH3 आ गया. ये पहला वाला aluminum chloride वाला था, ठीक है? So is this clear?
जी सर.
So then the next one is moving to the next one. You have SiCl4 with water, and that also is a vigorous reaction. SiCl4. Why does there's no you don't really have to really know why SiCl4 reacts with water, but you just need to know the reaction. It's a very strong hydrolysis. You get SiOH4 and HCl. But I'll explain what the reason is for that. Why does Si react with water? Okay, the answer to that is silicon, is it electronegative or not? Is it a non-metal or a metal now?
सर अगर क्लोरीन के साथ कर रहे हैं तो मेटल मान लेते हैं.
Silicon is a non-metal, right? Silicon has high electronegativity as well. So silicon normally has how many bonds? कितने वो उसके साथ bonded है? It's SiCl4, right? So normally silicon makes, it's got 4 electrons, so it normally makes how many bonds? It makes 4 bonds, right? It attracts 4 electrons from Cl and bonds with it. लेकिन तो कितने, how many electrons does it have now in its outer shell? It's got 8 electrons, right?
जी सर.
And I explained to you that it's very electronegative, so it likes to gain electrons. It's a non-metal. Non-metals always like to gain electrons, right? So can it gain more electrons at the moment? उसके outer shell में कितने electrons होंगे? What did I tell you about pH3 elements? They can have a maximum of कितने होंगे?
There's still space there.
So there's still room. Even after 8 electrons, there's still plenty of room for electrons, right? So what happens is that silicon is still capable of attracting water molecules. And it's going to attract these electrons because it's got more protons. It's got more protons than aluminium. Its nucleus has 14 protons, so there's more attraction for electrons. So the water molecules are going to come in and they're going to bond with it. And when the water molecules with its electrons, they come in, the Cl ions will sort of kind of get knocked out, right? So eventually what will happen is that the silicons are going to get knocked out and the oxygen are going to replace it. Okay, so that's the basic idea. Okay, so most non-metals, the chlorides, they end up reacting with water. The reason is because they're very, very electronegative. Okay, that's the reason. But in this case, you don't really have to know any detail as such. You just need to know that SiCl4 is a colorless liquid. You mix it with water, you've got a vigorous reaction. The chlorides get replaced by hydroxide. And the Cl and the H, they form HCl, and that's also strongly acidic. And you're going to get a very strongly acidic solution, and there's going to be, सारे cases where you're going to have, whenever HCl is formed, you're going to see misty fumes of HCl. बल्कि white लिखो तो ज़्यादा बेहतर है, white fumes of HCl. And have rapid reaction releasing fumes of HCl. PCl3, PCl5 will also have a very rapid reaction, and they would end up reacting with water, forming phosphoric acid and HCl. Okay. So PCl5 will form H3PO4, PCl3 will form H3PO3, and HCl gas is going to be produced. Sare cases where there's going to be fumes of HCl that are going to be produced. Is this all clear?
Sir, do we need to know anything else about the phosphorus chloride reaction with water, sir? No need, right?
No need for that. Okay. But it's the same basic idea that a non-metal likes to gain electrons, right? So it's going to attract the water electrons. So that's why it's going to be very reactive. And so now the acid-base nature of the oxides. The first two are basic. Sodium oxide, they're metal oxides. They're proper metal oxides, and they're very, very basic. And so they're going to react with HCl, and they're going to form salt and water, right? So aluminium oxide, on the other hand, is amphoteric. Amphoteric means that it's going to react with both acids and bases. With HCl, it's going to form a simple salt and water. With NaOH, it's going to form this thing, which is sodium aluminate. And the sodium aluminate has many different formulas. You can either call it NaLO2 or you can also call it NaAlOH4. So you have to remember this reaction. The other ones are acidic. SiO2 is a very weak acidic. I mean, that's sand. It's very weakly acidic. Reacts with NaOH, but only when it's hot and concentrated, and ends up forming a silicate, which is Na2SiO3, and water is produced. The other ones, oxides, P4O6, P4O10, SO2, SO3, they're all acidic oxides. When you think of them, always think like if you think of SO3, think of it as a reaction of H2SO4. तो आपने उसको H2SO4 समझ के ना अपने reaction लिखना है. Like if you react with NaOH, it's going to form Na2SO4 and water, right? SO2, think of it as H2SO3. SO2 plus NaOH, it's going to form Na2SO3 plus H2O. Those same acid-base reaction. So you got to remember which ones are basic. Sodium and magnesium are basic. Al2O3, that's amphoteric. It can do both things. SiO2, weakly acidic. And then they are strongly acidic. Is this also clear?
जी सर.
Yes.
तो ये equations वगैरह include relevant behavior and equations. You must learn all of these, right?
So, sir, only for these elements, not any other elements, sir?
No, not for any other. It's just period 3. But
सर जिंक भी.
नहीं, period 3 में zinc तो नहीं है.
Okay, sir.
That's period 4, ठीक है? You actually have transition metals, but that's A2. Okay. So that has, I mean, the D block elements, they have zinc, etc. So you don't really learn about it right now. As a period 3 में atomic radius across the group, what happens? It decreases. The radius of the atoms from sodium, magnesium, aluminum, silicon, and so on across the period, it decreases. Why does it decrease? They all have the same shells, right? Like sodium has 11 protons. I mean, this one is sodium. And at the other end of the period, you've got Cl, it's got 17 protons, right? But once you have more protons, there's more attraction for electrons. You've got the same number of shells. So since there's more attraction for electrons, the size of the atom kind of shrinks. I mean, shell-wise, it's the same atom, right? But the more protons you have, the more or stronger attraction for electrons you're going to have. The electrons are going to be closer to the nucleus of the atom. Is that clear? Okay, size of the atom decreases across the period. Is this clear?
जी sir.
Yes.
So then the cations are going to have a smaller size than the atoms because they lose their outer shell, right? But जब sodium का ion होगा ना, that's going to be smaller in size because the outer one electron is gone. And anions, they're always bigger in size because they actually gain electrons. So when you form a negative ion, you have extra electrons. And when you have extra electrons, the electrons kind of repel each other. So the electrons will be kind of like further away from each other. So the size of the atom will actually be bigger than the size of the ion will actually be bigger than the ion, bigger than the atom. Okay? Clear है बात?
जी sir.
Yes, sir.
अच्छा, अब ये कि एक है वो solubility of salts है, you should remember that. ठीक है, that's just something extra that's from O levels. You should know that it's got nothing to. पहले period 3 पे ही focus कर लेते हैं. अच्छा, period 3 के अंदर there's a thing called dative bonding. You have to remember that aluminum chloride dimerizes. ठीक है, that means कि aluminium and Cl they actually form a covalent. I mean, they form a covalent molecule. Why do they form a covalent molecule? एक से मैं उसका वो खोल लूं. So why do they form? अच्छा, ये आ गया. So why do they form a covalent molecule? Because the difference in electronegativity is not very high. Cl over here is 3 and aluminium it's 1.5. So if you have a very large difference in electronegativity, then one of them gains electrons, okay? But over here, Cl is not able to gain electrons because the difference in electronegativity is not very high. Cl wants to gain electrons, but the difference is not very large. Okay? It has to be larger than 1.7. This Cl can form an ionic bond with Na. It can steal an electron from Na because Na is very less electronegative. So can't do that with aluminium. So this case, you don't really have a covalent bond. Now, when aluminium makes a covalent bond, how many electrons does it still need to complete its outer shell? Does it have space in its outer shell?
जी सर.
Or yeah, other side, aluminium is a period 3 element, right? So its outer shell can have like a maximum of 18 electrons. Right now, it has very few electrons. It actually has 6 electrons. I mean, the 2 electrons share 2 electrons, 2 electrons. So that's a total of 6 electrons. So what happens is that in aluminium chloride, aluminium needs electrons. It borrows or shares electrons with Cl or attracts Cl's electrons. That's a dative bond. A dative bond is where both electrons are contributed by just one of the atoms. So Cl has 6 electrons in its outer shell that are not doing anything. So Cl is able to donate or share electrons with aluminium. Aluminium needs 2 electrons, so they end up forming a dative bond over here. The same thing happens with this aluminium as well, that it borrows electrons from Cl, shares electrons with it, and in that way, aluminium has 8 electrons now in its outer shell. So two AlCl3 molecules have joined together, and that's known as your dimer. Is that clear?
जी सर.
So ये
So
dimer,
there's another one, Al2Cl6 as well, right?
yeah. There's two versions of AlCl3. That's when you heat AlCl3, it actually at a lower temperature, around 180, it's below 180, it's actually in the form of Al2Cl6. And higher than 180 degrees centigrade, it actually, I mean, this is higher than 180 degrees centigrade, the molecule breaks. And it forms a smaller molecule, which is AlCl3.
Oh,
So this is dimerization. Dimerization is like polymerization is when multiple molecules join together. Dimerization is when you just have two molecules joining together. अच्छा, अब ये कि अच्छा बाकी ये कि ये flame test कर लो जल्दी से. Flame test, we just finished it. Flame test is that sodium burns in oxygen with a bright yellow flame, magnesium burns with a bright white flame, aluminum burns with a bright white flame as well. Silicon doesn't really burn. It's got a slow reaction. Phosphorus burns with a yellow flame and sulfur burns with a blue flame. So you got to remember these flame colors, and that's pretty much it. Okay, we did the structure of phosphorus before. So there are two forms of phosphorus. There's just some additional information. Phosphorus is P4, and there's another version of phosphorus which is a polymeric form of phosphorus, where the ends of the phosphorus they bond with the other one, so they form this polymeric form of phosphorus. Okay, so that's about it. That's all period 3 element. Okay, so we'll in the next class we'll do some past paper questions about period 3. But in the meanwhile, you just I think I've shared the board link. Have I shared the board link?
No, not yet.
चलो ये मैं share कर दूंगा. You just have to remember all of this. ठीक है? So make sure you keep a printout. It's pretty hard to remember most of it right now, but eventually just keep going through it. ठीक है? So जब तक exam होंगे ना, you'll probably get used to it. ठीक है? Okay, everyone.
Allah Hafiz.
Okay, Allah Hafiz.